Right, in this video I'm going to be working through the 2021 BC number 3, and so this will be the third problem on the operational version of the AP Calculus BC exam. And this is the spinning top problem, or the spinning toy problem. This one's been, it's generated a lot of good discussion in my class today, is what I'll say. So, find the area of the region in the first quadrant bounded by the x-axis in the graph of this. Find this area for c equals 6. Okay, maybe I'll copy that down. Okay, we can do this. So what we're going to do is we're going to say, well, I'm just going to say that this is going to be the integral. We know how to find the area under a curve, right? We're going to just integrate this from 0 to, well, whatever that intercept is. And we're going to be integrating 6x times the square root of 4 minus x squared. We substituted c equals 6. We're ready to go just as soon as we figure out what is this intercept here. And so what you need to think is, where is y equal to 0? Y is equal to 0 when x is equal to 0. C is a positive constant, they told you in the statement of the question. But where this could be x equals 2, right? There's more of this graph that happens down under here, I think. Maybe, yeah. But we don't need to worry about that because, again, they told us to just restrict our discussion to the first quadrant. So this is x equals 2, regardless of what c is. And c is really just like stretching it this way, determining how big your spinning toy is. All right, so the integral from 0 to 2 of 6x times 4 minus x squared, square rooted dx. All right. This is a u-du situation, right? I'm going to need to use u substitution because the derivative of the inside of a composite function is appearing with multiplication on the outside. So I will say I'm going to let u equal 4 minus x squared, okay, so that du is negative 2x dx. Now I have 6x dx, so I'm going to multiply both sides of this equation by negative 3, and so negative 3 du is equal to 6x dx. You know, maybe you do your u substitution a different way than me, and that's fine. You're going to get the same thing. Oh, and then I also need to, convert my x's to u's. Okay, so x equals 0 is going to give me u equals 4 minus 0 is 4, and x equals 2 is going to give me u equals 0. Okay. So this is now negative 3 du. I'll just factor out the negative 3 preemptively, and I'll say I'm integrating from 4 to 0 u to the 1/2 power, square root of u, du encapsulates the 6x dx. All right, now I'm going to anti-differentiate. I'm going to bump up the power by 1, divide by the new power. So u to the 3/2 multiplied by 2/3. But what I'm going to do is I'm just going to hold this 2/3 out here, and then I'm going to say, well, this is 0 to the 3/2 minus 4 to the 3/2. And this is a safe place for us to stop, especially on the no calculator section of the free response, or no calculator part of the free response section of the AP exam, right? This is a number. This is, I'm pretty sure, equal to 16. Okay? If you wanted to take it farther. But if you were on a time crunch, you definitely would not want to take this any farther and just move on to the next part of the question and try to solve it. All right, so let me copy the next part. All right, in part B, they said, well, if the radius of the largest cross-sectional circular slice is 1.2 inches, then what's the value of C for that particular spinning toy? And so, I don't know if I've mentioned in this video, but the whole idea of the problem is that you rotate that around the x-axis and you get some sort of spinning toy. And so, the largest cross-section is going to happen, well, wherever this is biggest, right? I'm just looking for the highest point here. That will give me the largest cross-section when I rotate it. And that highest point, well, that will come when dy dx equals 0. And they said specifically that radius of that cross-section has got to be 1.2. So what I'm saying is y needs to equal 1.2 anytime, or not anytime, at the time where dy dx equals 0. Now, fortunately, we've got an expression for dy dx. dy dx can only equal 0 when this numerator is 0, and we're only interested in positive x values and positive c values, well, that's going to be where x is equal to the square root of 2, and I'll show you that. So I'm going to say, 4 minus 2x squared equals 0, so 4 equals 2x squared, and x squared equals 2. And we're only working over here in the first quadrant, so I'm going to be confidently saying I'm only interested in the positive square root of 2. So I'm going to say, well, x equals the square root of 2. And I've got an equation for y, right? Yeah, y is equal to 1.2 is equal to c times x, which is the square root of 2, times the square root of 4 minus x squared. Well, x squared is 2, 4 minus 2 is 2. I've got another square root of 2 here. So that means to me that 1.2 is equal to 2 times c. I guess really c times 2. Meaning that c is 0.6. Okay. Again, if you knew what to do, this one wasn't that bad, but it was really tough for people to look at this one and know just what to do. Okay. And I get that. All right. Oh, yeah. The part C is a really interesting problem, I thought. They said volume equals 2 pi cubic inches. Find me the value of C. Love that. I think that really, the more I think about this problem, this is like a AP Calculus teacher's AP Calculus free response problem. I really like this problem, honestly. I think it's great. But I don't know that I would have liked it when I was taking calculus for the first time. So what I'm going to do is I know that volume is equal to 2 pi. I also know how to find that volume, right? You had to know that's where it was going eventually. So this volume is going to be equal to pi times the integral from 0 to 2 of r squared dx, where r is just this radius, so it's y. Okay, I'm going to actually copy down y, so it's cx times that square root, and I'm going to square that dx. Okay, and then maybe I'll just set that equal to 2 pi right now. Yeah. Now the first thing I'm going to do is I'm going to divide both sides of this equation by pi, just so I don't have to be worrying about that, right? It's one less thing. Then I've got this equaling 2. But I know when I square this, I'm going to have a c squared, and I can factor that out in the front. So maybe I'll write that. So I'll have a c squared integral from 0 to 2 of x squared, and then I square that square root. I'll just get a 4 minus x squared here. And that's equal to 2. But I'm just going to start by dividing both sides by c squared just to get just this integral. I'll work on that, and then I'll figure out what c is after that. Okay? And I need to get rid of that because I just divided both sides by it. All right. Now, I'm going to say, well, I can actually compute this integral by doing that distribution. Right? You might see, oh, product in the integram, there's no derivative of something else, I should use UDV. But remember what I told you about UDV. You start to think about UDV and you're going to do I late. And then you remember algebra plus algebra equals algebra. Okay, and these are both algebraic. So, anyway, I'm going to actually do the distribution, and I'm going to have the integral from 0 to 2 of 4x squared minus x to the 4th dx equaling 2 over c squared. Now, I'm going to just do the computation down here of the integral, and then I'll do the rest of the algebra maybe on the next ones over there. So, what I've got is, hold on, what am I thinking? Oh, 4/3 x to the 3rd minus 1/5 x to the 5th as x runs from 0 to 2. Well, that's going to be 8 times 4 is 32 over 3 minus 32 over 5. All right. That's too bad. So what I'm going to do here is I will say, all right, 2 over c squared equals 32 over 3 minus 32 over 5. And, if you're real slick with fractions, maybe you combine that into a single one, but you'd be no more right than I am. I'm getting a number here. I'm in the process of it. What I'm going to do is I'm going to multiply both sides by c squared, and then I'm going to divide away that horrible number here, which I think is 64 over 15, but it's just not worth it, you know? What if I was wrong? And so I would say that c to the 2 power is going to be 2 over 32 over 3 minus 32 over 5. And so that c was equal to, now I'm only interested in the positive square root because if you go back to like the fine print in the statement of the question, they say c is a positive constant. So 2 divided by 32 thirds minus 32 fifths. Okay. And this was 2021 BC number 3. This one was a real great problem in my opinion. But hopefully, hopefully this was explanatory. If you found this helpful, why don't you like the video?